Um, Hopefully you can hear me. Hi, welcome guys. Hope you're having a good weekend. Feel free to say hello in the chat if you haven't already. And it'd be great to hear from everyone. We're about to begin. We're looking at rounding today. So a nice GCSE topic just in preparation for the upcoming exam season. So I hope everyone's well. Do feel free to say hello and let me know how it's going. It would be great to hear from you, questions and answers as we go through the session today. So yeah, we're going to be looking at rounding and kind of number work. And I'll shortly share the PowerPoint and begin. Do feel free to say hi. As I said, I'll keep an eye on the chat throughout. Welcome. Thanks if you've just said hello. Feel free to share answers and questions throughout, and I'll try and answer those live as we go through it. Hopefully it's going to be quite nice content and just sort of an easy, gentle reminder, a bit of revision in preparation for the time of year we're at and the upcoming exam season. So I'm going to get started now, and hopefully you'll all be able to see shortly the lesson we've got prepared. I'm good, thanks. I hope everyone's doing well. How are you guys doing? All right? I hope we're having a nice weekend and everyone's keeping well. I'm going to make sure I'm sharing the correct thing, the rounding PowerPoint. Here we go. And yeah, welcome if you've just joined as well. Thanks for the messages in the chat, guys. I'll be keeping an eye on those. Hopefully that's now sharing with you the GCSE Maths rounding page. We're going to get started looking at this idea. Some of you might be familiar with the advanced information and you've kind of looked at topics that are coming up. Obviously, this is a key part of the number topic. So whether you're in year 10 or 11, this is a good topic to sort of review, rounding and bounds and stuff. So I'm going to get started. But again, if you've just joined, feel free to say hi and welcome. It's great to see people joining and giving up some time on a Sunday for some maths revision. That's brilliant. Excellent. Right, let's get started. So we're going to look at understanding the difference between decimal places and significant figures. So they're kind of key mathsy words we'll hear all the time, and they're very specific in the exam about that, what they're going to want you to do when you see those words. Hopefully it's sort of fairly familiar. Some of you might have seen this before. We're going to look at rounding to a given amount of decimal places and significant figures, but also look at bounds in terms of error intervals and limits of accuracy, because this is quite a picky topic that they do like to examine. And it catches people out quite a lot. So I think it's an important one. It's not a particularly mind-blowing topic. There's nothing too deep or abstract about it, but it is a topic that costs people marks. So I think it's really important for us to look at this today. And as I said, please do feel free to share answers and questions in the chat as we go. And I'll be doing my best to answer those as they come in. So let's get started then, and we'll just go through the specifications. So very quickly, this is something that 100% is on all the different exam boards. So it's a key part of number at GCSE. So whether you're with Edexcel, AQA, OCR, rounding is a key skill and actually quite a useful skill going forwards, especially any maths application-based subjects. So your sciences and stuff as well. Now, looking at this number here, just very quickly, being really careful because they could sort of phrase this in different ways, but obviously the number here, we're looking at how it's broken down. We've got like the tens of thousands column. And so that's the place value there, thousands. And they might say to the nearest thousand, but they might also use the word significant figures. And then we've got hundreds, tens, and units. And then it's just being careful and rounding it correctly. So for this one, if you guys could let me know in the chat, first of all, that number there, if you could round it to the nearest thousand, what would we get? Let me try and write the number correctly again. So just so we can see it. So this number rounded to the nearest thousand would be what? Hi, welcome if you're just joining. Lovely to see messages coming in. We're just getting started. So hopefully the first bit's sort of fairly straightforward, but we're looking at rounding in light of how it comes up in the GCSE today. So welcome. Hi, if you've just joined, and if we could have some answers and some questions, if necessary, throughout, please do ask. So this first one, rounding this number here, 31,359 to the nearest thousand, what would that equal? So how would we round this number to the nearest thousand? What would it be? Brilliant, thank you. If you've just shared some answers, that's superb. Yeah, nice and clear as well. I appreciate that in the chat. That's lovely. So to the nearest thousand, because this three here in the hundreds column is less than 5, that tells us that this will round down to 31,000. So well done if you got that. That is to the nearest thousand. Now, to the nearest 100, if we look at the hundreds column and we look to the right of it, well done if you've got an answer for this already. But that 5 is going to indicate that this will round up to the next 100. So this will be 31,400. Very good. Thank you, guys. Excellent. And then the next one to the nearest 10, well, we're actually going to look at the units column. So this is the tens column. We're going to look at the units to determine whether it rounds up or stays the same. And because it's a 9 and 9 is greater than 5, this is going to round up. So to the nearest 10s, to the nearest 10, this one will be 31,360. And I know this sounds like hopefully really straightforward, which is really reassuring if it is, but be careful because some people go, oh, 60. But that number, that whole big number is not going to round to 60. That's the bit at the end. So make sure you write out the number in full, rounding it carefully. But thank you for the answers there. We're going to keep going. We're going to push through onto some slightly trickier content as well. So in general, just looking at rounding then, let me just start this off. So what we're going to do is a kind of few keynotes, a nice gentle reminder, and then some exam questions. So we use rounding to basically, I know this might be obvious, but simplify. And it's actually kind of a practical aspect of where you're going to use maths probably going forward in real life. Simplify long, complicated numbers. And it is a proper skill. It is something we need to know how to do effectively, efficiently, and accurately. So simplify long, complicated numbers. And also how we deal with that in calculations as well. We've got to be very careful. So to round to a certain number of decimal places, basically we're going to count the number of decimal places. And we've kind of done this skill already. But feel free to do the next one for me and put it in the chat, the example we're sort of illustrating here. So count the number of decimal places. And then what we're going to do is use the next number, as I'm sure you're aware, use the next number on from where we are. I know what you mean. I know the feeling. It's a little bit annoying, isn't it? Yeah. Just looking at the comments in the chat there. Yeah, in shops and with money, it's sometimes a bit annoying. Everything ends up being just easier to round it, isn't it? So use the next number to determine whether to change the last. So let me know if you've rounded this one. Let's see if we've got any answers for that. Whether okay, so if you've rounded this, we want to round 0.002807140 to 5 decimal places. So for this one, what we do is we count the decimal places, and well done if we've got some answers. So 1, 2, 3, 4, 5. Now the next number is this one here. And since 7 is greater than or equal to 5, we round up. So this one, now don't worry if you went further, because what we're going to look at is significant figures in a minute. So some of you might have gone like a step further here. If it wants it to decimal places, and there are issues with this, there's a reason why decimal places aren't always the best way to round. But to 5 decimal places, this is actually the value. No worries. No, and I do really appreciate that, because where we're going with this is significant figures. And actually significant figures, in my opinion, we're going to argue, I would say, is better to use. But obviously, if they tell you how to do it, we've got to make sure we do the correct one. But in general, I would actually advise do significant figures. Right, well done. Let's keep going. Hopefully everyone's happy with that. So a few rounding to decimal places examples, if you guys want to give these a quick go. And again, if it's 2 decimal places, not significant figures, we look to the third to determine what way it goes. So a quick little practice of these. The first one here, round 0.537 to 2 decimal places. So the thing we're going to use to determine it is the 7. Does that make it go up or stay the same? So if you want to start putting some answers in the chat, guys, that'd be greatly appreciated. And I'll fill them in live as we go as well. So that means that the 3 rounds up to 4. So we end up with this one as 0.54. Well done if you got that. So let's try the next one here, if we can. We'll maybe do this one next, and then the third one. And then we're going to whiz on and look at significant figures. And I really would like to stress the impact of why significant figures are important, especially from a sort of science perspective as well. Some of you might be fully aware when it's appropriate to use what. Obviously, if they tell you exactly how they want you to round it, you must do it that way. But yeah, this is great. Well done if we've done this. So 2 is less than 5. So that one's going to round down to 0.01. Very good. The third one, 1 decimal place, where the 2 is less than 5. So that's going to make it round down to 10.3. And finally, this one, 55.555. 5 is greater than or equal to 5. So the 5 rounds up to a 6. So we get 55.56. Very well done if you got that. That's lovely. So let's keep going. This is really good. Now, significant figures. And just as a side note, you might be fully aware of what this is, but I really want to make this crystal clear today. A significant figure is a digit which is sorry. An amount after the first non-zero yet digit in a number. And I think it's easier to see with examples. So basically the way I kind of describe it often is it kind of is what it says on the tin. The significant figures, where the number kicks in, basically. So if it's a really massive number and it's like 20,000 and something, the 20,000 is the first significant bit. But if it's like 0.000005, the 5 is the first significant figure. It's where the number sort of kicks in and takes its magnitude. So, right, let's have a little look. Yeah. Good. Yeah, I've just checked. I hope I haven't missed any questions, but if you are, I can see, I think I can see the chat coming through. So if you are asking questions, please continue to do so. I think the answers have been really good, but I'm not sure if I've missed any questions. Do feel free to send that again if I have. But yeah, really appreciate the answers coming in there in the chat. So what I was mentioning is significant figures is where it sort of the number takes its first sort of significant part and it kicks in. Can anyone suggest why this might be better to use than decimal places? Why significant figures in terms of a scientific point of view or a practical application? Why we might choose to use significant figures instead of decimal places? When would there be a problem always using decimal places? I'd be really interested if anyone could suggest that in the chat, because it's actually a really important point we maybe don't pause to think about. When is significant figures better or more appropriate than decimal places? So count, the way to do this, we count the number of, I'm going to abbreviate it to sig figs. And start at the first non-zero digit. Cool. And if you would like to try and do this one for me here, which some of you maybe recognize, it's very similar to the previous question, but this time it's significant figures we're rounding with. So first non. Yes, excellent answers coming in. I'm going to pick up on that question in a second. So we're going to use the next significant figure to determine how it rounds. And then we'll do this example. And whether to change the value. Now, the question I asked was, I asked if when it's more appropriate to use significant figures. And actually, yeah, if you think about scientific kind of context, if it was something really, really tiny, there was a brilliant example there. If it's on an atomic level and it's really, really small, everything would just round to 0. So there'd be nothing to calculate. Whereas from a scientific point of view, you'd want to look at where the number actually kicks in and say, right, well, this is where it sort of starts being significant. So everything's down at that sort of magnitude. Let's round to the most important part of the number. So we sort of get a sense of the magnitude and we can still work out calculations rather than just making a sort of a rule to just use decimal places. So that was a really, really brilliant answer there. And something we don't often think about, we just do what it says a lot of the time. So this one here, we've got an answer for this, round 0.002807140 to 5 significant figures. So I just meant really tiny kind of particles you might deal with in physics that are really, really, really tiny in length and their mass might be really small. And if you were trying to work something out, rounding it to 0 wouldn't be much good. So yeah, that's all I meant with that example. But so here, this one here, that's the first significant figure of this number. Let's look at it. Where does it sort of kick in? The first significant figure is actually this one. So 1, 2, 3, 4, 5. So they're the 5 significant figures. So we're going to use the 6th significant figure to determine does it round up or down. Now, since 4 is less than 5, no problem. That means that it will round down. So your answer will be 0.002871. Cool. Well done. Right, let's keep going. So a few more examples. If you guys would like to give these a quick try in the chat, I'll whiz through these in a second. So some questions here about rounding to significant figures. That would be great. And then what we'll do is we'll do a couple of exam style questions and push on to look at error intervals and stuff. So give these a quick go. If you want to give these in the chat, that would be great. Let's deal with these carefully because all of these calculations are rounding to significant figures as opposed to decimal places. So let's give these a quick go. And as I said, it'd be great to check them in the chat. So I'll just give you maybe 30 seconds or so to see how we go. But brilliant. And thank you so much to everyone sharing answers and questions in the chat. Hopefully so far this is kind of manageable stuff, but it's things that we need to look out for and be very precise on. This kind of topic in an exam will be quite brutally an all or nothing. You get it right or you don't. And it's just about being very specific and paying, close attention to detail. So here we go, 0.537 to 2 significant figures. Well, that's the 3rd significant figure. And so that will tell us to round up. So this will go to 0.54. And for this case, for this one, very good. Thanks, guys. This would actually be the same as if I said to 2 decimal places, just because that's the kind of number we're dealing with. But that won't always be the case. So for example, this next one, 0.0128 to 2 significant figures. The first significant figure is here. The second significant figure is here. This is the 3rd significant figure. So the 8, right, then are equal to 5. So that'll tell us the 2 rounds up to a 3. And that's what we'll get for that one. Right, let's have a little think about the next couple. So 11.32 to 1 significant figure. I'd be interested what we get here because it's easy to go a little bit wrong with some of these sometimes. Think about what would that round to 1 significant figure. What is the first significant figure? What's its magnitude? What sort of number are we dealing with? What do we get for this one? So 11.32. Brilliant. Excellent answer. So this second significant figure is a 1, which is less than 5. So it means it rounds down. So this 11 will basically round down to 10. And it's see so many easy mistakes here to sort of say stuff like, oh, it'll round to 1. 11.32 is never going to round to 1. That figure will round to 1, but it actually represents 10. So be really careful with that. Right, excellent. And then the last one, absolutely right. That's the second significant figure, and this one will make it round up. So this will round to 56. Very well done. Thanks so much for the answers, guys. This is great. Let's keep going. So a couple more. I think they're worth doing, and then we're going to push on to some exam questions. And as I said, look at error intervals as well, in light of the kind of GCSE questions we would get. So round 0.016542 to 3 dp. So this time it's decimal places. So the first two questions are to decimal places. The second questions, like the final two questions, they are to significant figures. So we've got to be very careful and pay close attention to detail here. How does it want me to round each number? So the first one, it wants me to round that number to 3 decimal places. So as soon as the decimal point happens, everything is something we're considering. So 3 dp, 3 decimal places. And how will that round? So that's the first decimal place. That's the second decimal place. That's the third decimal place. This is what we're going to use to determine it. 5 is greater than or equal to 5. So the 6 rounds up to a 7. So this number to 3 decimal places will round to 0.017. And that is 3 decimal places. It's not the same as 3 significant figures for this one, because the number doesn't sort of kick in until here, but that's actually the second decimal place. So hopefully everyone's happy with that. Now the next one to 4 decimal places. So again, it's 4 positions after the decimal point. So this one, let's be careful. 5 is greater than or equal to 5. So the 9 rounds up to a 10. So actually this will round to 31.69. And then because that rounds to a 1, that carries over, we get 90. And hopefully everyone's happy with that. Now the next one to 3 significant figures, and then to 4 significant figures. So same numbers as before, but this time we're dealing with significant figures. So if you guys could let me know this one and this one in the chat, that'd be greatly appreciated. And then we'll look, as I said, at some exam style questions and go from there. So let's see if we've got some answers for rounding these to some significant figures. 0.016542 to 3 significant figures, and 31.69895 to 4 significant figures. So let's look at where the number kicks in. So the first significant figure is here. So 1, 2, 3, and we're going to use the 4 to determine what happens. And thanks very much if you've shared an answer. And that applies to everyone today who's used the chat to share answers. That's greatly appreciated. Thanks very much, guys. Well done with that. Now, the next one, the first significant figure is actually here. The number kicks in the 30s, 31.69895. So the 8 is the thing that determines it. And that will make it round up. Since 8 is greater than or equal to 5, the 9 will go up to a 10. So this will round to 31.70. And well done if you got that. Yes, absolutely right. Yeah. So you're kind of going ahead of where you want to be to just sort of determine how it rounds. Very good. So guys, if you could give me a 1, 2 or a 3 in the chat, just to let me know how kind of confident you're feeling with this before we look at some exam questions that are typical GCSE exam style questions. That would be really helpful, just as a little checkpoint for me to understand, you know, how we've pitched this, but also how you're finding it ahead of doing some GCSE questions. So just a 1 for straightforward, 2 for if it's kind of okay, or 3 for super confused, which I hope isn't the case, and certainly doesn't look it from the chat. But yeah, that'd be great to hear just a 1, 2, or a 3, just a little indication from people. Thanks very much if you've done that, just to get a sense of how we're feeling with this. So straightforward, a 1, okay, a 2, and then 3 if it's quite confusing, but hopefully that's not the case. So, right, well done. So feel free to share that if you haven't already, just a 1, 2, or a 3. We'll look at some exam style questions now, which I am about to share with you. So here we go. Right, so this one here, we'll whiz through these little 1 markers, as I said, all or nothing, and then they'll get a little bit trickier if you want to type these straight into the chat. So write 4.47367 to 1 decimal place and to the nearest whole number. So let's give this a go. That'd be great. So if you want to share answers in the chat again, that would be great. And then, yeah, we'll see the different kind of ways this can come up in an exam. This is very kind of like matter-of-fact style question. Right, work this out, do it. Here it is, 1 mark, very sort of straightforward, but we'll look at how else it could come up as well. So a few GCSE questions to try, and then we're going to look at error intervals. So write that number to 1 decimal place. Thanks very much if you've done that. Well done. So 4.47367 to 1 decimal place, well, the 7 is going to make the 4 round up to a 5. So this will be 4.5. Very good. The nearest whole number, well, actually, that's the units column. The 4 will make it round down. This number is closer to 4 than it is to 5. Well done. Thanks, Rhea. That's lovely. Right, let me move this down. So another question here, a GCSE kind of style question, 2 marks. Calculate this thing here. And you can actually do this on a calculator. So this would be a calculator question. And then it says, give your answer correct to 2 decimal places. So if we type this in, if anyone wants to type in the chat what they got when they type this into the calculator. So rounding could be a calculator paper skill. And what we would get if we type this in, I believe, is going to be 4. Okay, just check you agree with that. Clearer. Now, lovely, excellent. So if I want to round this to 2 dp, to 2 decimal places, let's look at where that happens. Well, that's the 2nd decimal place. So it's this one that tells us whether it goes up or stays the same. And since 7 is greater than or equal to 5, we round up. So our answer will be what? So it will round this one up. So yeah, so to 2 decimal places, the 7 will go up. So it'll be 4.38, but to 1 dp, it would be 4.4. And actually to 2 significant figures, it would be 4.4. Yeah, so that was a really good point, actually. 4.4 or 4.40, that's actually the answer to 2 significant figures, but 4.38 to 2 decimal places. Very well done to everyone there. That was good. Right, and one more kind of GCSE style question before we look at error intervals. So what is the number 80,953 written to the correct 3 significant figures? Give your answer. So this is one where it's sort of multiple choice and you just circle it. Effectively, though, you just want to work it out still anyway, and hopefully you'll see your answer there. So we're looking at rounding this to 3 significant figures. Which one is it? So this would round up to 10. So it's this one. Very good. Now this next one, what is that number rounded to 2 significant figures? Very well done. So 2 significant figures, that's the 3rd one. That will make it round down. So hopefully with this, we're happy. This one here. Cool. Well done, guys. We're going to keep this moving. So what we're going to look at now, limits of accuracy. And this sort of stuff is generally considered, kind of towards the harder end of the number content. And it is quite a common type of question. Yeah, absolutely. And you know what? It's these sorts of skills that are really underestimated. And people do cost people a lot of marks. So an error interval is the set of numbers. And I always felt like these questions, I wasn't exactly sure what they wanted me to do. So this is what we want to clarify today. So the set of numbers that could have been, oh, pen went a bit weird there, that could have been rounded okay, and then limits of accuracy are basically the maximums, maximum and minimum Right, I'm just going to read that question that's come through. So, right, so actually it's a really good question about using 5 and being really careful, because I've seen people make the mistake with the bounds as well. The 5s are always the boundaries. We have to sort of set it somewhere. But if it's 4, 9, 9, 9, 8 or 9 something, that isn't quite 5, then that's still in range. As soon as it's 5 or more, it always goes up, and that's where the cutoff is. It is at exactly 5. So we'll see how we can maybe denote that, but I think that's a really good question. So looking at this one here, and looking at how we write it, and hopefully this will shed a bit of light on that question exactly there. Now, it might be tricky to write in the chat, but I'm going to show this as an example. Can anyone suggest what the boundary numbers are, what the limits of the accuracy are? So what's the lowest value the thing could have been that would have actually rounded up to 630,000? This really good question. This could be both. This could be either. I think the harder questions of this stuff are more likely to be higher tier. But especially the way we're going to write this quite formally, but certainly rounding could be on either. So limits of accuracy and bounds is generally a higher topic, but I think it's good to prepare for both. So thank you for that question. Basically, what we know is that this could have been anywhere between that number that number there, and so if I put the limit there as 625,000, and I'm going to put the upper limit. Now some people write it as 634,999 0.9 recurring, but that is actually the boundary. Now, the way we show this formally, because we know that would round up, but anything sort of ridiculously close to it would still round down. So the way we write this mathematically is in the following way, and this is really important. So say X is the number it could have been, that we're saying what could have rounded to that. Then what we've got is this lower boundary. Hopefully everyone can see that this means X is between 625,000 and 635,000, inclusive of this value, but strictly less than this value. So it means it could have been that value or more, and it could be up to, but not including this value, because 635,000 would round up. Does everyone see that? Has everyone recognized that this notation means in between? I'm just using the letter X to represent the true number that has rounded to given us this. But that will be somewhere between here and here. And it could have actually physically been that value, but it can't be that exact value because that would round up to the next number. But the boundary is where the 5s lie. So we put a strict and a non-strict inequality to show if it can take the value or not. Does that sort of make sense? Now, some of you have answered the next one and given me the limits, given me the sort of boundary values, and absolutely right as well. I'm going to just write this in the same way. So 38.5, 39 is sort of in between, and then 39, which is effectively 39.5 as the boundary. So for this one, I'm going to write it in this way. Is that okay for everyone? Does that sort of make sense up to there? We'll do a couple more of these, but I think these questions are really important to go through. And they're not necessarily easy, like knowing to do that isn't necessarily obvious, but I think it's not letting that inequality notation phase us and recognize that that just means the true number could have been between here and here. It could be that. So I'll give you an example and do let me know if you're still unsure, because I think this is the harder bit now. But basically, is everyone happy if I give you some examples of numbers that would round to 630,000 to 2SF? One example could be 631,298. If I said round it to two significant figures, it would round down to 630,000. Are we all okay with that? Do we all agree with that? Another example could be 626,495. That would round to 630,000. So what we're doing is we're saying, what can the numbers be between that if I said round it to 2SF, they would all round to that number, 630,000. Well, basically anything between 625,000 is going to round up to 630,000. And anything from 635,000 and below will round down to 630 if we're rounding to two significant figures. But the boundary value of where it changes is 635,000. And it's at that value it would actually then round up to the next thing. It would start rounding up to 640,000. So that's a strict inequality because everything up to that value, but not including it, would still round down to 630,000. Does that make sense to everyone? So I think this notation catches people off guard. I really struggled with this at GCSE, knowing that you could write it in that way and not letting it like bother you that we can use an inequality to express an interval. That just means between here and here. So this whole X thing just means the number, I'm calling it X, call it any letter you like, but it lies between here and here, inclusive of this, but not quite include. That's the boundary. So the two boundaries are always the 5s, but that tells you whether it can actually take that number or not. The true number could have been any number in between. We're just setting the limits. And the same here. Many of you said in the chat, I know the numbers are 38.5 and 39.5. That's absolutely right. You got it right then. That's brilliant. But I'm showing you how you would write this, how you would express this as an interval using the correct kind of notation. And you don't need to think much more deeply than that. It's just handy to know that that's how we would express it. So I think we should do a couple more before doing some exam questions on this. So the value 0.433 has been rounded to 3 decimal places. So this question is asking what it could have been. So it could have had a lot more decimal places. Where would the cutoffs be? So we know that the lowest thing it could be is 0.4325. Does everyone see that if this was the number, the 5 would make that round up to this? And the highest thing is 0.43. because that's the cutoff of where it wouldn't round down anymore. And 0.433 is what everything in between would round to. So this means that the number is between those boundaries. It can be that value, but it can't strictly be that value. Very good, right. Excellent. So for the next one, let's identify that straight away because that's the main bit. The boundaries absolutely are 425 and 435. Superb. So this one, the original value could have been anywhere between that and that. Oops. Inclusive of that, but not of that. Very good. Okay. So be careful, truncate. I think that depends on the example. That's where you literally just sort of chop the number off at that point. So if it's like 3 places, you just write the first 3 and you don't even round it properly. You just chop the number there and you don't look to the right of it. Good question. So little checkpoint on that. And then, as I said, we'll do a few exam questions of this. So you can see exactly how they might bring this up in an exam. So just be honest, just a 1, 2, or a 3. Thank you for the questions and answers again, though, guys. And that goes to everyone. That's really, really brilliant there, because some of these have been quite tricky now. Lovely. That's fine. Let me know in the chat, and we're going to keep going. So it'd be good to hear a little checkpoint from everyone that can. Great. Okay. Right, let's have a little look at some exam questions. So, Mia cycled 23. Excellent. Thanks, guys. That's lovely. And thank you to those responding. It gives me a good update as well. So Mia cycled 23 kilometers, correct, to the nearest kilometer. What is the least distance Mia could have cycled? So 23, we're rounding it to the nearest whole kilometer. Well done. Thank you for the answers there. That's brilliant. Could have been anywhere between 22.5 and 23.5 is the boundary. So the lowest distance she could have cycled was 22.5 kilometers. And to the nearest kilometer, we would round that up to 23. Great. Now this one, it says the width of a bench, B, is 984.8 centimeters. Correct to 1 decimal place. Write down the error interval for the width of the bench. So if something has been rounded to 1 decimal place and it's come out like that, then we've got to think, what could the second decimal place have been? What are the boundaries? What was it between? And like I said, always remember the 0.5s. For this one, the lower bound, what would make it round up to that? 984 point something something. Brilliant. Thank you very much. That's lovely. Letitia, that's great. Brilliant. Superb. Well done, guys. That was brilliant. Hopefully that's clear for everyone. But as I said, please do ask any questions. If not, feel free to share any questions in the chat. Okay, right. Another exam question here. Another sort of couple of exam questions. Let's have a little look at this one. Lovely. Well done. So a number X rounded to 1 decimal place is 4.7. So the error interval is that. A number Y rounded to 2 decimal places is that. Let's write the error interval down. So Y so if it's rounded to that, we've got to think what were the 3 decimal places it could have been. So 4 point something, something, something. And that would be 1, 2, 5. Right, and a number Z rounded to 2 significant figures is this. So that's 1, that's 2. So it's this one we care about. So this one here, very good. Brilliant answers. Thank you, Jack. That's lovely. So this one here, this number Z, oh, I don't know what I'm writing here, could be between what? So we're going to the third decimal place, and we're thinking what would be the lower bound and what would be the upper bound. And that is good. Oops. Sorry, it's just so they're a good little flavour of how it could come up in the exams as well. Thank you so much for the answers and the questions there in the chat, guys. So hopefully what we've got. No worries. And this is actually a really important skill that will cost people marks all the way through. It will cost people marks at GCSE, at A level, and trust me, beyond as well, at university. So be really careful rounding. And also the point of it is quite important. So understanding the difference between decimal places and significant figures and why one might be more important. And then recognizing error intervals. Yeah, absolutely. Did we want to go back to this one? Is that what you were asking about, Letitia? This one here. So this first one here, where it says 4.13 to 2 decimal places, that means the boundary is in the third decimal place. So what we needed to do for that is think about what would round up to 13. So that'll be 125. Think of it as like what rounds to that. You're going to the third decimal place. So it's like, imagine it's 130. It would be between 125 and 135. That might be a better way to visualize it. But if it's 2DP, the bounds are going to be in the third decimal place. So hopefully that's made sense of that. But thank you for asking to clarify. Let me know if that's okay. But yeah, that was a really good question. So yeah, being careful with bounds, looking at error intervals, limits of accuracy are all really important, good, specific questions. So thanks very much, guys, for your answers and your questions throughout this session. Hopefully this is something we're feeling fairly confident with. Oh, okay, no worries, that's okay. Hopefully that's cleared it up now. Sorry if that's the case, but hopefully that makes sense now. Well done to everyone. Good luck to anyone with any upcoming exams, and keep working hard, keep well, and yeah, really well done again. Thank you for taking part again. If you've got any questions, let me know, and thank you to those that have already asked questions and sent answers in the chat. So let me know, but otherwise, guys, really well done. We have got more upcoming web classes, so keep an eye out for those. That's lovely. Thanks for the comments and the helpful questions and comments throughout, guys. Very good luck. I'm sure you guys will do great. You're working really hard and dedicating your time on a Sunday, as I'm sure you have been throughout the whole process. But really well done and best of luck with any exams you've got. Keep focused, do your best, and I'm sure that'll be the kind of key to a successful exam. But really well done, and thank you all again. Take care, guys. Keep well. I'm going to stop that there. But brilliant work. And yeah, as I said, one final time, good luck with any exams, and hopefully see you at a web class in future. Cool. Thanks, guys. Well done. No worries. Take care. Bye.